So hello guys, Team Syntax here, and our problem statement title is Hybrid Renewable Energy and Generation Solution. So let's look at the problem first. As we all know, Rajasthan has a surplus amount of solar and wind energy, but we can't utilize it. This is the blog of Economic Times, which gives you all the information about that. Let's move forward and look why we are not able to use the energies. So, as it is mentioned in the problem statement itself, the crux of the challenge is not about hardware, but it is how we are managing the hardware. We already have hardware like solar panels, windmills. There are many big solar plants set up by governments and also by private and public sectors, but it is not used efficiently. How they are not used efficiently? Let's look at that. So we have a real world problem of Bhadla Solar Park, and they have mentioned the challenges that they are facing in Wikipedia itself. So let's read it. One of the main challenges has been dust accumulation on solar panels, which reduces their efficiency and output. This is one problem. This is a real problem faced by Bhadla Solar Park. Let's move ahead. Okay, this is Rising Rajasthan's site. Okay, the Rajasthan need to increase their power efficiency and also the production by 2030, as it is mentioned over here, by almost three times. And what are the solutions that we are with? Let's look at it. So here are the problem sets and all the solutions, but we will understand this through our prototype. So we are at the dashboard of our prototype. Here we can see we have 9 solar panels and 5 windmills. But how this works, how it has to be worked, we will understand this through our bottom to top approach. Let's go to setting first. Let's go to API. We have installed EMO and CMS API for smart meter API. Smart meter API, what does this do? This actually takes the real-time data and send it to our software from the smart meter which is attached to the solar panel. And same as for open weather map API, for data source API, which is already installed in the system. Then we move to alerts. We can get alert on 20% or 90% of our battery level, and for efficiency threshold and for grid import limit also. And then we have billing section. In billing section we have billed it for 0.1915 rupees per kilowatt hour, and same as for grid export rate. These are standard rates which we are having. Let's move to weather. This is the first step of our system. We need to set our location. Then the overall total solar area size, which I will take for 200 kilowatt. Why we are doing this? Let's know. So we got the total estimate out. So this is the ideal estimate, means this is for 100% efficiency of the data we have provided. This means we have to actually compare the actual data with this ideal data for knowing the efficiency of our system. Let's go to asset. Here we can add our assets. Likewise we are having 9 solar panels. So let me add one more solar panel. So similar type. Let me take 200 surface area and panel efficiency is 25%. Let's take it 30%. Save configuration, add the solar hardware. So now we can see we are with 10 solar panels and capacity is also increased. Let's go to dashboard. Okay, in dashboard also it is updated and wind assets are still 5. Here we can get the information of the solar production, which is inactive now because it's night when I'm recording. Wind production, battery storage, grid status, and also total assets. Grid status is also 0 kilowatt because we are on the wind production. We are working on the wind production, so we are using that energy. So grid export is also 0. Total assets are here. So we also have the diagram to understand this, and then graphs to understand this for today. Also for last 7 days we are getting the diagrams, but the best part of this thing is the data history. Okay, how this data history helps. Okay, this is taking data for every 5 second. Here we can see this is for 8/18/35 and 8/18/40. This is a 5 second difference for the here, and we can also download the Excel file. Let's open it. Okay, here we can see we can open the Excel sheet. Okay, this data can be used to compare the actual data with the ideal data that we got. This is used to get the efficiency. Here we are having the efficiency. This is how we are calculating the efficiency. So this was for our the software. Let's move to a PPT. So we are done with this solution set. Now we're going to technical approach. So we have used APIs that we have mentioned recently for fetching the data from the smart meter. Then React.js, JavaScript for basic things we do in a website, Node.js, and especially MongoDB for storing all the data. The data is still stored here, and also calculations are also stored here. So this is also an important part, MongoDB. Let's go to feasibility and viability. Most important thing. As technically we will face one problem if we are not having a smart meter installed. It is a very rare thing because in modern day smart meters are installed in even in windmills and even on the basic small scale products also. But if it is not available, then we will unable to connect the software through it. So this is the major drawback of our system. And also data reliability. If the meter is sending us the wrong data or faulty meter is sending the data, then we can't do anything. It will make nuisance to our software. And obviously impacts and benefits, this all things gives one solution, which is efficiency, energy efficiency, which was needed in our problem, and which was what we have to give, which is efficiency. These all things sum up to the efficiency, energy efficiency, and utilizing the hardware at its best. So that was all from our side. Thank you so much.